Starting a new unit on Newton's laws of motion. We've been talking the last couple units about how theories grow and develop and how one scientist builds off the work of other scientists. The motion theory goes all the way back to Aristotle, who came up with the original theory. And his theory lasts for hundreds of years until Copernicus moves the sun to the center of the universe, and along the way really starts to question the theory of motion in general. The next guy in the story is Galileo Galilei, and he is trying to prove Copernicus right and prove Aristotle wrong. The way that he goes about trying to prove Copernicus right is through some thought experiments that involve inclined planes. The first thought experiment was to roll a marble down an inclined plane. And when he did this, he observed that the marble started to go faster. And when he rolled a marble up a ramp, he saw that the marble started to go slower. So he wondered what would happen if there was no slope. What would that do to the speed? He knows that it can't behave the same as rolling downhill or uphill, and he knows that when it gets to that flat that it doesn't stop. So he concludes that it must be now moving at a constant speed. His second thought experiment involves two inclined planes, and he rolls a ball down one of the inclined planes and lets it roll back up the other inclined plane. And what he notices is that its final position is about the same height as its initial position. So he begins to play with the angle of the second inclined plane, and he lowers the angle, and he notices that the ball continues to try to reach its initial height. Now he knows it has to travel further to get to that same height. And he begins to wonder what would happen if there was no slope at all in the second inclined plane, if it was perfectly flat. And he reasons that it's going to continue to roll forever and ever because it's never going to get back to its initial height. So, according to Galileo's observation, the ball, when it hits that flat, is going to want to roll at a constant speed forever and ever. Then the question becomes why? Why does that continue to roll at a constant speed forever and ever? And Galileo explains it using an idea called inertia. And inertia is just the property of a body that resists change of motion. And that's what leads us into Newton. So the first thing that we need to know in this unit is what inertia is. Galileo really does a good job of explaining what happens to the ball, but doesn't really get into the why it happens. The why, again, is what leads us to Sir Isaac Newton. So Newton is born a year after Galileo dies, so they're not working together. Newton just builds off of Galileo, just like Galileo built off of Copernicus. Newton comes up with 3 laws of motion by the time he is 24. And also comes up with the universal law of gravity. He builds off Galileo's concept of inertia when he comes up with his first law of motion. So learning target number 2 is to know what Newton's first law of motion is. Newton's first law of motion is also sometimes known as the law of inertia. And I think in the past, most of you have probably learned that things at rest want to stay at rest, and things that are in motion want to stay in motion. And if you want to change that motion, make something move, or make something that's moving stop, you're going to need to apply a force to make that change in motion. That's a very simple version of Newton's first law. The one that I'm going to give you right now is a little bit more precise. It has 5 components to it. You know probably most of them, but I'm going to add in 2 more that you might not be familiar with. Better version of Newton's first law is this: every object continues in a state of rest or of motion in a straight line at constant speed unless acted upon by an outside force. So in addition to it just staying at rest or staying in motion, we have to describe the motion. And that motion is always going to be a straight line and a constant speed. Last unit we talked about velocity, and we defined velocity as both speed and direction. So if you have a constant velocity, that means that you would maintain a constant speed and you would maintain a constant direction, or a straight line. So we can really replace the first four components of Newton's first law by referencing velocity. So a smaller, simpler version of Newton's first law would look something like this: every object maintains constant velocity until it is acted upon by an outside force. So an object at rest that stays at rest really just means that it's going to maintain a constant velocity of 0. And if an object is in motion and maintains a straight line and a constant speed, that's the same thing as saying it's maintaining a constant velocity. We'll talk more about this later on in the unit. But when we say an outside force, that's not really true. What it really should read is an unbalanced force. So the final version of Newton's first law that I want you to know is that every object maintains constant velocity until it is acted upon by an unbalanced force. So what are some of these outside or unbalanced forces that can act on an object? One of them is gravity, another is friction, and a third would be air resistance, which is actually a type of friction. And then the fourth outside force is really a force that's applied to that object by any other object. Now the first three on that list are natural forces, and the last one is an imposed force. So anytime you see an object changing its motion, it's going to be due to one of these four things.